Here, mathematical modeling example case studies we are going to study in this video. So, number of videos are there. Watch it on my channel Kadam Academy. And here, bicycle. See, this is the bicycle. This is a two-wheeler. That is a motorbike. And this car just quarter car. It's how the quarter car and how we can do the physical systems or these actual models into physical system in mathematical model. So, and what you learn after watching this video for this bicycle, two-wheeler and quarter car, after completion of this video, you are going to understand the introduction to physical mathematical modeling, and after that learn analysis vibration problems and steps to find out the replace the physical system by a mathematical model. What are the different steps you will learn? After that, the mathematical modeling for the bicycle or the two-wheeler, that is the motorbike, we are going to study here how to develop this mathematical model. Here, the case study of the mathematical modeling of the quarter car you are going to learn. On this slide, introducing the physical and mathematical modeling, you must learn what are the physical model and the mathematical model. Mathematical modeling from physical model of vibratory system we are studying here. So in real life, most structures and machine systems have elastic members with the dynamic system, hence have an infinite degree of freedom. Already we have studied in degree of freedom video. We can watch what are different type of degree of freedoms. For such vibrating system, physical system, the dynamic system for which the variables are there, that is the excitation and responses, and which are time based. These are time based responses and excitations are there in each vibratory systems. Okay. So response of vibratory system mainly depend on what? Their initial conditions and the external excitations. So these vibratory systems are very complicated and hence they are difficult to analyze, and to solve problem solving of such vibratory system are need to do analysis very properly. For that reason, physical system is converted by drawing mathematical model. Okay, so in engineering problems or various machines or the various whatever the machinery we are using, they are having infinite degree of freedom. So that problems maybe we can say when there is a infinite degree of freedom, that will be the continuous system, or we can distributed system with the complicated differential equation, and we have to replace that complicated equations into simple solutions with the solutions, simple equations with solution. These differential equations become accurate and we can solve and analyze that the continuous system, which is difficult to analyze, and hence they are generally analyzed by converting them into discrete or lump parameter system. So this procedure of modeling is same for all engineering fields. Okay. So, but the details of modeling varies with the field. Whatever the field is there, according to that, the modeling will be different. So we'll study in different video the different modeling system. Okay. What is the lump parameter system? We'll see now. In this lump parameter, helpful by considering or converting them into concentrating them into individual property of vibratory system. Individual property of vibratory system. To replace this physical system by mathematical model, different 4 steps are there. Okay. So these 4 steps I will show you one by one. The following procedure. First step is what? Conceptualization of the physical problem into mathematical model. We'll go in detail in this one. Second is the derivation of the governing equation of differential equation of motion. So this we have to derive the governing equation for this mathematical model, and this mathematical model were formed or drawn by using this physical problem or physical system. Okay, the physical model were converted into mathematical model, and were derived this governing equation or differential equation for this mathematical model. And now what, after this got the equation, solve the governing equation for a specific, what are the conditions are given, boundary conditions, or the what are the external forces are there, by using the various methods. Okay, and lastly, interpretation of that solution obtained in a step 3, and its application in design. That is the 4 steps. We study one by one. The steps of this vibration analysis of the vibration problem usually involves following steps. First is the conceptualization of the physical problem into mathematical model. That is the physical model going to convert into mathematical model. And here, what will happen in this step? This is a very basic step. Okay. While converting the physical system, mathematical system, its main purpose is to represent all the important features of the system for deriving the mathematical equations. The behavior of the system without making the complicated. The mathematical equation of governing equation, we get it by considering all its features. Mathematical model may be linear or non-linear. Here, decision to be taken whether the structure should be treated as a continuous, that means the multi-degree or infinite degree, or some standard degree, number of degrees. And with the advantage of considering the lump parameter system, means what? All the features were to consider of that system. With the degrees of freedom we have to finalize. And we will have the location of the lump masses. Also, the excitation causing it must be given. What are the excitations? What are the responses? How is the response due to this excitation causing? And that mathematically feasible form, that we have to just decide it. So what will happen then? That by using the Fourier analysis also we can solve this conceptualization physical problems. So here, this mathematical model may be linear or the non-linearity, with the equation that depends on the behavior of the components of the system. Means whatever the different parameters we are considering for that mathematical model, that is considered. Okay. So next step is what? Deriving the governing equation. Derivation of the governing equation or in the form of differential equation. This could be done by first principles of dynamics. It's based on this first principle of dynamics to derive the equations that describe the vibration systems. Both equilibrium method and energy methods can be employed for this one. So resolving the forces couple by drawing FBD, means free body diagram of masses, is considered, and equation of motion is derived by considering all the mass, inertia forces, reactive forces, or the external forces, etc. The choice depends upon the convenience of the resulting the analysis. Whatever the forces and masses are given, that will be, that system may be linear or non-linear, that may be discrete system or the continuous system, and according to that system we have to just derive the equation of motion. That equation, suppose the discrete system, that equation becomes the ordinary differential equation, or suppose in continuous system, that equation becomes the partial differential equation. Under this deriving this governing equation of motion approach, various approach we can use. We can use the energy method or this FBD energy method or the FBD or the equilibrium method we can utilize. Next step will be the solving the governing equation of specific boundary condition and external forces. Means what this in this third step, that will be whatever the surrounding problems while solving this problem solving in vibration system with the high degree of freedom and complexity is there in the system. Suppose to solve it by governing equation by using the various techniques are there, that Laplace transformation, matrix method, or numerical method. Like this, the various, considering this initial condition, we can form that utilizing these various techniques, we can solve that governing equation. For some complicated equation, computer programs are also used. For the calculation purpose, it is not possible and difficult to conclude the behavior of the system by using the that will be easier by using this computer programming. Okay, so response of the physical system is obtained by solving that equation, that is in step 2. So it may be necessary sometimes to use the transforms like a Laplace transform to solve the equation, or the multi-degree system harmonic solution for the each mass may be assumed to natural frequency determined by the matrix method also. Friends, last step is the interpretation of the mathematical this equation or results. Whatever after getting the solutions, these results or solutions obtained in step 3 and its application in design, and as a vibration as an applied science, results obtained after the solving the mathematical model equation of motion. The solution of the governing equation gives the suppose the displacement, the amplitude, we can say the amplitude, and after we can calculate the velocity. Similarly, we can calculate the acceleration, time period, frequency, natural frequency, different masses of the system can be found, and the analysis of vibrating system can be done by using the above results. So friend, like this we can solve the mathematical modeling equations. This mathematical vibrating system, before considering, already I have shown that lump parameters. So what is the lump parameter? Most of the structural machine systems have the elastic members. Okay, hence the finite degree of freedom of such system are referred to as continuous system or distributed system, and analysis of this system requires the complicated differential equations. So what will happen? This solution of this differential equation of complicated equations would give the accurate results. So however, the continuous systems are difficult to analyze, and hence they generally analyzed by converting them into discrete or lump parameters. In simple language, दोस्तों मैं आपको बताता हूँ. This continuous system means what? The infinite degree of freedom. Okay. For this purpose, this is the one of this part of that system. Okay. This part is converted into simple the discrete lump parameter. We can say the discrete system. This continuous system is having the multiple degree, but here only 1 degree of freedom. That is conversion of this mathematical model. While converting this one, it is useful. So this step is very important. As the name suggests, the lump parameter system concentrate the individual property of the vibrating system. Means last that shown you this this is the one rod. Okay, it is converted into spring mass system. Okay, that this delta is the displacement. So it is converted how these can say here this lumping property of mass would be considered that complete mass concentrated at the center of gravity, and on similar lines the property of elasticity can be considered by lumping the elastic responses. So what we have done here, we have just converted this system into simple this procedure of vibrating system replaced by the physical system and mathematical model. So by converting this continuous system into discrete system, just we have converted the physical system into mathematical model for the getting the solution. So like in this, that rod is considered with the property of elasticity, with stiffness K, and the mass of this lump property of the elasticity. Using this method, any practical system can be broken into various elements, thereby reducing the complexity of differential equation, and carefully development of the mathematical model would give the reasonable accurate solution. And here, see, this continuous system, if we write one equation for this system, so that equation may be difficult to solve, but for this system it is very simple. Differential equation will got it. Most of the elementary kind of the continuous system would be an elastic rod, that is the shown in this figure A. Okay, this is figure A. This bar can now be converted into lump parameter system by concentrating the mass, this mass concentrated here at the center of this bar. An axially loaded bar, the axial deflection of the self weight would be given. So this K that will show it's a self weight. Okay, and this system is converted like this. This distributed one, the lump parameter system. So this del, how we can calculate for this continuous system elastic rod with the cross-sectional area A, modulus of elasticity E, and its mass is m. And how to find out this deflection del? By using this formula mgl by AE. That means the W into length of this elastic rod in denominator AE. How to find this K? We can find out W by del. That means AE by L. Here W get cancelled and AE by L is remaining. This cross-sectional area, modulus of elasticity, and length of bar, and that equation we can derive by for this lump parameter. Okay, so friends, now with this learning with the case study of mathematical modeling of a quarter car, and in this before going to this see the picture of this car is shown to you with the new model. Here the suspension system is there in every car, is one of the most important part of the vehicles, which can reduce the impact loads from the road. Whatever the impact loads come on from this road, that will reduce, and that will improve the automotive ride comfort and stability of that vehicle. The stability of vehicle that depend, and the ride comfortness will depend on this your suspension system. So friend, here one of the very known and useful model of the study of the comfort or stability of the car is quarter car model suspension system, and that consists of 1/4 of the car or one wheel we have to consider for the study of the suspension system. So this red part is shown to you in this diagram. That means this is suspension system we are going to study further to get the more calculation, give the more comfort to and stability of this car. For sure, some assumptions are adopted on that model, but that doesn't detract the numerous engineering applications using the dynamic system. So what will happen here? The vertical vibration of the vehicle we are analyzing. What we are analyzing? Vertical vibration of this vehicle we are analyzing. And this quarter car model suspension system, it consists of 1/4 of the body. Okay, this 1/4 of the body that will include the body mass and the suspension system and the one wheel. This one wheel it is considered. During this mathematical modeling of this following one of the assumption that tire model has a linear spring. The tire is model. The tire which is moving on this road, it is considered as a linear spring without damping, or with damping also we can consider. Effect of friction is neglected in this case. The spring damper is considered as a linear. Okay, this quarter dynamics of the model is shown to you. the consider as a 2-degree system where there are two bodies are there, sprung car and unsprung car. Sprung means the car body, unsprung means the suspension, tire, wheel and tire mass we are considering. Although it is the simplified model, stiffness of the damping of the systems are used so as not to consider everything, and which is the not represent the physical model. So hence, between the road and suspension, the stiffness of damping of the tire and wheel is considered between the suspension of the car. Okay, so I will show you this spring mass. Unspring mass means the body mass, and in between this body and this tire, unspring mass means this considered as the wheel, tire. Okay, the suspension mass, these are unspring mass, and this spring and suspension connected to the body, that is the spring mass. Okay, and the in between this tire and this surface, uneven surface, that we are considering as some spring property of this tire. So contact between these two, here frictions are not considered. Frictional effect of friction is neglected. This is the conventional suspension system mathematical model for this quarter car. So it is represented that the representation of this quarter car is there. The model simplified, a very simple, widely used mathematical model to analyze the vibration and control problems of the vehicle. The quarter car model, this represent only the vertical motion. Already I told you, this vertical motion of the vehicle and body wheel is considered. The vertical dynamics of vehicle can be investigated by using this model. Vertical dynamics of the investigated in this model. If we add here the damper with the controlling system, here this is a very simple passive suspension system. We cannot control anything of the spring stiffness or the vibration in the spring or the damper stiffness. Okay, the resistance of the damper we cannot control. Suppose we were to control it, that will be by the semi-active. Semi-active means what? They have control electronically control active suspension system, which will having the damper properties can be controlled. Here damper property can be controlled. That will become a semi-active, we can say, the suspension system. Okay, some of these companies, they are providing the like this suspension system. How we are traveling on this road, what kind of road, according to that we can just utilize that semi-active suspension or the full active suspension system. In that electronic control active suspension system, there will be actuators and this variable dampers are we can utilize, and the rider comfort we can improve by means of the reducing the car body acceleration caused by the irregular road or the disturbances from the not on the smooth road, but this disturbances by the road that will be disturb the rider. Okay, or this vehicle, the car body also accelerate due to this one irregular disturbances. Okay, so this active suspension system is there, but this is a very simple passive suspension system. Here there is no control, but for this is a mathematical model. What is our purpose in this video? That we learn the physical system of this car is converted into quarter car. The quarter system, this 2-degree system, where this considering the sprung and the unsprung masses, they are represented in the mathematical model. So from this mathematical model we can easily derive this equation of motion for this, and we can find out the frequency for our system. So this is the easily shown you here. to find this equation of motion. What is that symbol here? MS. MS is what here? This body. Okay, body mass. Okay, there is sprung system. Okay, the values are given for just for know you the 2500 kg. Okay, the KS is what here? This is the KS for the spring constant for suspension system. This is the actual suspension system. That values of this is near about 80,000 Newton per meter. And this damping constant, CS is the damping constant of the suspension system, 350 Newton second per meter. And this MU is what? Suspension mass. Okay, this total system having the some mass 320 kg. And this KT is the spring constant of wheel and tire. This wheel which is moving on this uneven surface, that the KT, the spring constant we are considering here, that will be the C. Value of the spring constant is how much? 50000. Okay, so this Farad Newton per meter. CT is the damping constant of this wheel and the tire. Also value is given 15,020 Newton second meter. So friends, this is the mathematical modeling of this quarter car. Okay, if the you can also calculate by using this one. This is the quarter car system mathematical model, that sprung, unsprung, this KS, CS, damping, all this shown to you. If we consider for this every wheel, okay, this for the half car, we can show half car, and this is the full car. The diagram is shown for the full car. We can considering all these parameters on the for 4 wheels, and just adding that we can create one equations for this all the car. And how to solve these equations? Now there are Altair software is there. On that software we can easily get the responses of that system or the car for the vibratory system. Responses we can calculate by using different softwares are available. You can make career in that field also. So friends, this is the mathematical modeling of the your quarter car we are studying. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes. And friend, here you always learn by self-assessment only, and you have to subscribe my channel Kadam Academy. If you are not subscribed, please subscribe it. Thank you very much.